there is something called selection sort also. Public. Okay, so this is basically a selection sort. So as the name the selection suggests, in the inner loop you're trying to select the minimum element, and once you have selected the minimum element, you swap it with the index I. Right. So it is almost similar to the bubble sort, but there's a few subtle differences. Here also, what is the time complexity of this one? And very straight, right? But in this case, what will the number of comparisons in the worst case?
It will be same, I think, n square only.
It will be same n square only. Who is saying this, Manoj?
No, it's the swapping alone you're saying, right? Okay.
Yeah, I'm just talking about the swapping. How many times the maximum swapping can happen?
Yeah, it would be n square.
Okay. How about Srinivas? What do you think? What should be the
It's n square only, I think.
n square only? Okay. And how about Vivek? You?
Maybe n.
Okay, so Vivek is saying n. So the answer is n, guys, and let's see why. So swapping is not happening every time, right? Swapping is not happening every time. So what we have done is that once the complete internal inner for loop runs, in that I have selected what is the index of the minimum element at that point, and after that only we're swapping with the index I. Right? So the swapping happens every time after once the complete inner loop runs, right? So the maximum time the inner loop can run is n times only. The swapping can happen only the n times, right? If it was happening inside this, then I will say that it will be n square, because in that case n square number of times this code will get hit. But since it is outside the inner for loop, it is here. So it will this line of code will get executed only till the number of times this for loop is executing, right?
Yep.
So in the terms of the time complexity, the selection sort and the bubble sort are almost same, but still I say selection sort is better, slightly better than the bubble sort, because in the case of the selection sort, the number of swap is less than the number of swaps in the bubble sort. In the bubble sort, it is the order of n square, and in the case of the selection sort, the number of swappings is of the order of n. Now, coming back to the relevancy of understanding the sorting algorithm, nobody will ask you at this stage of your career that you write a sorting algorithm. Nobody will ask you, okay? But they will definitely ask you a questions, the related algorithm where the how we are doing it right now will be helpful to you. So, for example, how I used a flag in the bubble sort, or how we are doing calculation in the case of the selection sort. These logic will definitely will be asked indirectly in the questions that you may face in the interview, or when you are solving the problems for an industry in the use cases. There also you can use this concept, right? So pay very strong attention to this small point, because the another seed that I'm going to share with you guys is based on the sorting algorithms. There will be no direct question of how to sort a particular thing, but at the same time it will be based on the logic that we are discussing as of now. Okay, so one extended question of this. So right now I have given you the bubble sorting algorithm by the iterative way and the selection sort algorithm by the iterative way. What your assignment is this, right? The bubble sort and selection sort using recursion. What you have to do is that you have to write a bubble sort and selection sort algorithm using the recursion. This is your one assignment apart from the seed that I'll be giving you. Fine? Any doubts on this?
No.
Perfect. The next assignment, this is one thing. The another pre-read that you have to do is that you have to read about merge, read about quick sort, and read again insertion. And when you are reading, try to do a careful reading of it. Try to think around those lines. How many times the number of swapping are happening? Right? Can I do anything in this code to tweak this? to further make it improve, right? Try to think on those lines now, right? Just don't blatantly read anything that okay, this is how it should go. Don't do that. Try to have a more focused reading in which you pay a key attention that where the swappings are happening, what are the conditional checks that are happening, how many number of times the swappings are happening. Try to pay importance to these all critical important things, and then you do it. Right. So basically, this merge sort and a quick sort has a better algorithm, which is n log n. One important fact about the merge sort is that every language has a inbuilt sorting algorithm, right? Whether it's a Java or it's a Python or anything like that. So most of the language where you use the inbuilt sorting algorithm, the underlying algorithm that they use is mostly merge sort, right? That is how important this merge sort algorithm is. So please try to go through this sorting algorithm. I'll also try to share you a sorting algorithm seed. Try to get started with the questions in that. If you're stuck somewhere, no problem, because there might be few questions in that seed for which concept we have not yet covered. So there's no problem with that. But try to solve as many questions as possible from that. I think if you read the merge sort and the quick sort on your own, and then you try to attempt that question, I think it will be much easier. But I'm not expecting you to solve all the questions. Whatever number of questions that you have solved, that is great. Right? All clear? Any doubt?
Sure.
Perfect.